Well, greetings, everyone. Thank you all for joining. My name is D.Barker. I'm the presenter today. A little bit of information about me. I've worked with the telecom industry for many years as a consultant and also developing products for network deployments. And I've been doing this a long time, since the early T1 point-to-point networks to the present fiber internet networks. This is the first of a series of technology presentations that Flytec is going to tell you about. And if you want to see future presentations, please advise Flytec and they'll sign you up. If you have questions during the presentation, please put them in the chat. And at the end of the presentation, we'll do a Q&A. I'll take about 30 minutes for the presentation. And if you need to contact me at a later time, you can do that through Flytec, and the last slide has the contact information. Okay, so let's proceed with the presentation. We're going to cover three areas. One is the review of the internet last mile connection, which is basically what we're replacing with fiber, and that's the connection from some central hub to the home or the office. The next section explains the optical fiber technologies. We're going to talk about the different components in the optical fiber network, and then finally the management, which is very important. Once we've built the fiber to the home or office, we have to be able to sell the internet service. And so we need to manage subscribers, we need to control that access to the network. And so we do that with a technology that I'll tell you all about. And finally, the challenges and benefits that ISPs who are going into fiber face. So the last mile, well, we have a number of competing technologies. You're probably all familiar with copper twisted pair, which is the DSL or ADSL. That was one of the first of providing high-speed internet into the home and office. We have the cable internet service. So cable TV provided first the TV service, and then protocols were developed, DOCSIS, to provide data over the same network. And now we have the fiber networks, passive optical networks, or gigabit passive optical networks that ISPs and telcos are busy installing. We have some wireless technologies as well that you're probably familiar with. First is the unlicensed Wi-Fi technology that many wireless internet service providers use to sell internet service to their customers, and Flytec has a wide range of products for WISPs. We have telcos who provide fixed broadband wireless to the home or office using LTE and now 5G technology. We have the low Earth orbit satellites. So services like Starlink provide an internet service. And then we have the geostationary satellite links, such as Usenet. If we do a quick comparison between these, we'll see that copper cable, the ADSL, provides us with speeds in the range of 10 to 20 megabits. The useful distance from the central hub is about 3 kilometers. We can extend the network, but we have to put electronics in the circuit to amplify and repeat the signal. And there are a limitation to the number of times we can do that. Coaxial cable is similar. We have a range of about 3 kilometers before the signal deteriorates, maybe a little bit longer than twisted pair. But once again, we have to put repeaters to extend the distance. Optical fiber, on the other hand, gives us a much higher speed. We're not limited to the 10 or 20 megabits that we get with twisted pair or coaxial cable. The GPON The gigabit passive optical network gives us 2.5 gigabits down and 1.5 gigabits up. And a single strand of fiber can give us that connection up to about 70 kilometers. And once we get that to the home, of course, we're going to connect that to gigabit Ethernet. And so the maximum speed the customer is going to get is gigabit. And we would split one fiber that goes from our central office for a number of homes. And so we have a passive optical splitter that can go from 1 to 16 ways up to 1 to 128 ways. That reduces the distance. So 1 to 32 way splitter reduces the distance down to 20 kilometers. And we would set rate plans for customers, which is basically a speed limit for a price, maybe 100 megabits or maybe 500 megabits speed. Wireless on the right there, we have point to multipoint WISP, which is unlicensed spectrum. Typically, we're getting data rates up to 100 megabits. We do have various point-to-point links up to a gigabit using unlicensed frequencies, the higher frequencies. The 5G telco service, the fixed broadband to the home, gives a better performance. We can get up to 250 megabits when we have the tower in line of sight, and the latency is low. The problem for the telcos is they do have a limited capacity, and so they have a limit to the number of subscribers they can offer 5G data services to over their network. The geostationary satellites, we're talking about maybe 10 megabits, 20 megabits data rate, high latency because the satellite is in a high orbit, 22,000 miles. So we're talking about several hundred milliseconds of latency in that network. The LEO satellites, low Earth orbit satellites, are only 300 miles away, so we have a much lower latency. Speeds can be up to 150 megabits per second, typically 100 megabits per second. Let me go to the next page. So service providers who are offering fast internet over fiber are looking to sell what we call triple play. That is a group of services. The cable providers already do this. The fiber providers want to offer, as well as broadband internet, digital television, voice over IP. There are other services, for example, security systems in the cloud that are being offered, hosted application, managed Wi-Fi. If you look at AT&T, you can see they have quite a broad range of services that they offer over fiber. The interesting point about fiber GPON is that the DOCSIS-like protocol that was developed does have the ability to configure quality of service, which means you can prioritize different data streams. And so that is an advantage for triple play type services. If we look at the pros and cons of fiber to the home, well, there are a lot of pros. High speed connection, we can actually offer customers up to a gigabit of speed. There are 10 gigabit fiber connections, so we can offer customers up to 10 gigabits of speed, although that would be a more expensive service. It's very reliable. Unlike copper, it's really not affected by electromagnetic radiation. The fiber cables are generally sealed from the elements and so are not affected by the weather. It's very scalable because we're using very high data rates, and so we can easily add more customers. And we see that it has a long life into the future. In fact, once we put a cable in the ground, as technology develops, we can put faster and faster data rates to that cable. And so the same fiber optic cable is going to be able to transmit data at 100 gigabits if we have the right equipment at each end of the cable. Now, The cons are the cost. Basically, it's very, very expensive to install fiber. If we're replacing existing copper wire, it's possible to use some of the infrastructure, but if we're looking at installing fiber to homes which are a long distance from the central office, then it becomes really too expensive to do that. And so right now we have limited availability, and other services like 5G data are probably more accessible for a lot of rural homes. Also, the ISPs offering fiber services are probably looking for longer term contracts to be able to amortize the cost. So it means you're depending on one service provider for that service. Now, those of you who are familiar with networking know that we have various types of modular systems that we recognize, and fiber is just the same. We have the central, the optical line terminal, OLT. We connect that to the homes through a fiber distribution, an optical splitter. And then at the home, we have the optical network terminal, and we connect a wireless router to the fiber optical fiber network terminal. And the photos there show some of the equipment, the OLT equipment, the ONT equipment, and the optical splitter. And there are various manufacturers who provide these. One word of warning, the DOCSIS type protocol that is used is not detailed specifically like Ethernet is. If you buy an Ethernet product, it will connect to anyone else's Ethernet product. That's not the case with fiber products. Generally, we have to buy the OLT and the ONT from the same manufacturer. There's no guarantee of compatibility between the OLT from one manufacturer and the ONT from another manufacturer. So a word of warning when we're purchasing the equipment for our networks. I mentioned the protocol, very similar to the DOCSIS protocol that the cable people use. We're able to set priorities for certain data types, and so real-time communications like phone or video communications can have a priority set. You know, if you're using Zoom and the screen freezes, that's because you're communicating over an Ethernet network and you're sharing the same data circuits. There's a lot of other types of communication. With GPON, we can set priorities, and so we're not going to get any frozen screens or crackly voice circuits as we would if we were having a plain Ethernet type of connection. Urban fiber, the fiber that's being installed, we usually install it underground. In a lot of modern communities, in fact, there are no utility poles. All the utilities are installed underground. We may have an infrastructure such as cable ducts where we can pass the cables. It may be in older neighborhoods, we have utility poles, and so we would distribute the fiber through utility poles. Nevertheless, the cost, you can appreciate the cost of installing the fiber cables is very high, especially if we have to dig trenches in order to install the cable. That's very, very time-consuming and expensive process. We would take one cable from the central office and we'd put a splitter in a neighborhood, maybe for a street, and then from the splitter we install drop cables to each home, and then each home has the ONT and the Ethernet wireless router. Rural areas, the method of connecting homesteads is different. We don't have groups of homes that allow us to connect a splitter. We probably have utility poles where we can string the cable along utility poles. And so at each homestead, we have a differential optical splitter, where we maybe split off 5% or 10% of the light, which goes to the ONT at the homestead, and the majority of the light continues down the cable, and we can maybe do that 20 times before the signal is attenuated too much. And so that would be the principal method of connecting homes to fiber in rural areas. We have several different splitting topologies. I mentioned the first one, which is the centralized or star topology, where we have the OLT at the central office. We send out a feeder to a street or an area. We feed that into an optical splitter, and then from the optical splitter we have drop cables to the subscribers, the homes. We do realize that the number of taps on the optical splitter determines the maximum distance. And so, as I mentioned, with a 32-way optical splitter, we can have a maximum of 20 kilometers between the central office, the OLT, and the ONT, the subscriber's ONT. We can cascade the splitting technology, as shown in the next diagram down. This obviously is going to reduce the maximum distance a lot more, but it facilitate the installation of cables in a city area. And so we can have a central office that has one feeder, goes to a stage 1 splitter, which may be in an area of a city. We then run fibers out to streets, and then at each street we put a stage 2 splitter, which has a drop cable to the home. I've already mentioned the optical tap topology, which we use for rural areas. And so we run a long cable along a road, and then the entrance to each homestead has a non-symmetrical tap, and so we run a drop cable to the homestead. We have other options as well. For example, a multi-core patch panel topology, where we're not actually optically splitting the signal. We run a multi-core cable to a distribution point, which has a patch panel. And so from that patch panel, we have a cable which goes to each home, the ONT at each home. This allows us to actually have up to 70 kilometers between the OLT and the ONT, because there's no attenuation due to splitting the cable. We could combine these. For example, we can combine the multi-core patch panel topology with the cascaded topology. So we can run multi-core cables to the stage 1 patch panel, not the stage 1 splitter, and then from that patch panel we can run cables to splitters on each street. And so we have various possibilities, and we have different components which we use to build the infrastructure. Let me just go up here slightly. Okay, so management of OLT, ONT products. Generally, each manufacturer provides software to configure the products. This shows the Ubiquiti fiber products. They have the Ubiquiti OLT and ONT. They call that the ONU. And so that software is provided by Ubiquiti to configure the systems. We use the VSOL equipment. The OLT has software built into it. You can connect through the console terminal, and you can use that to configure the OLT and also the ONT devices that are connected to it. So each manufacturer has a different type of software, and as you all know, if you install wireless networks, you're accustomed to having the software that is used to configure the devices, similar to, for example, Ubiquiti systems that you are probably already using. There are a number of different fiber equipment manufacturers. The main manufacturers, Adtran, CommScope, and Cisco, they're all billion-dollar corporations. Ubiquiti also has a good range of fiber products. and other manufacturers like Juniper have fiber products. There are also various manufacturers of the different components we need to build out the network, such as fiber cable, optical splitters, utility pole mounting parts, underground cable installation parts. There are a couple of Chinese manufacturers that have a lot of restrictions placed on them by the US government, the Huawei and ZTE. I think there are even restrictions now on importing those products, and for a while the sale of those products has not been permitted to an entity, a government entity. So if you're building out a fiber network, avoid those products, because it may mean that you can't provide a service to certain types of customers. So that's one precaution to take. Now, we've talked about managing or rolling out the fiber network to the customers. Now we have to talk about actually delivering a service, because the fiber network is one part of the solution, but we have to be able to sell an internet service, or internet plus video plus phone services to our customers. And so we need software on top of the network in order to manage the subscribers. We also have a component in the network called the broadband network gateway. So the diagram there shows how this is connected. The OLT does not connect directly to the backbone, the internet backbone. It connects via the broadband network gateway. And this product is managed by the software, and so it activates customers onto the network. It enables or disables those customers according to the status of the payment, and it sets the rate plans for those customers, which is the maximum speed that the customer is permitted to use. It might also set, for example, data limits. Some ISPs might decide they're going to put a monthly data limit on the customer. It also gathers data about the network use and sends that back to the software management system. And so the software management obviously has the billing component, which allows us to invoice customers every month and collect those payments. The sales staff can add new customers. The support staff can help customers. We have a help desk system, customer relationship management, and so the customers can ask questions and get answers. The network technical staff also use the system. They get work orders when a new customer is signed up, because they have to install that customer. They have to install the drop cable from the hub to the customer's home and install the ONT in the customer's home. So it's a system we call the ISP management system. All ISPs have this. The biggest ones like AT&T will have a billing system called Amdocs, and they will buy the broadband network gateway from Cisco, and that will be a multi-million-dollar type management system. Smaller ISPs have systems which are scaled down for their applications. So if you have a few thousand subscribers, you can manage those with an EasyWisp system, a more basic type of management system, but you're looking at something that may cost less than $10,000 to install, compared to $1 million for a large telco system. Now, the ISP would want to continue expanding the network, and so each central office will have a limit to the number of subscribers, because we have maybe a 10 gig circuit into a backbone. Maybe we can build a larger network with 100 gigabit circuit into the backbone. It really depends on what we have available. If we're looking at smaller areas, villages or small towns, then maybe we have a limit to the number of subscribers. Maybe we can only hope to sign up 1,000 or 2,000 subscribers in that area. Maybe it's a rural area and there are less subscribers. And so what the ISP will do is set up a number of different central offices according to the ability to sell services to those customers. And we have two options. We can have all the central offices routed back through a tunnel to one network management gateway, or else we can set up the management gateways at each sub central office, and we can manage those through the cloud system. So the telco will have various options to configure those networks, and so it means the telco can expand the services with really very few limitations. The only limitation is the ability of the telco to invest, or the ISP to invest in the infrastructure. And as you well know, the government have made available a lot of money to help ISPs build out that infrastructure. Last year, well, 2001, the government approved $45 billion, which right now is fueling a lot of fiber installations. Those installations are not yet at a point where customers are receiving service, but within a year or 2 years, those fiber installations will be operational and customers will have access to a much faster internet service. The broadband network gateway is basically a high performance server without much data storage, but one device like this, it's got a throughput of 10 gigabits and can manage several thousand customers. The fiber distribution network connects to the broadband network gateway. We authenticate the customers onto the network. We verify the customer's identity in order to permit that customer have access to the network. We have a step where we verify the status of the customer so that the billing system, if the billing system doesn't note that the bill has been paid, then it can deactivate the customer. And then the next stage is the access rules. This is the maximum data speeds, maybe a data cap, maybe we have other rules that are part of the rate plan for the customer. And so the broadband network gateway is communicating the customer's data through to the internet via the circuit to the wholesale provider, and the gateway is also receiving its instructions through the backhaul to the backbone via the API, which controls how the customers can access the network, and also gathering data and feeding it back to the central management system. The software functionality at first sight might seem a bit complicated, but if we look at the diagram, it's pretty clear. In the middle there, we have the broadband gateway, network broadband gateway. To the left, we have the subscriber's fiber infrastructure, which we've talked about. To the right, we have the backhaul network infrastructure, the data link, 10 gigabits, 100 gigabits circuit into the wholesale provider. Middle left, we have the sales department who enter the information about new customers. That generates two steps. One is to add that customer to the subscriber database. The other step is to generate a work order for the field service technician up at the top right, because once the customer signs up, we have to install that customer. That means putting in the fiber drop cable to the home and installing the equipment in the home that the customer will need to access the network, the ONT and the wireless router. At the bottom, we have the manager who is looking at reports and also sets the rate plans, which is how much we're going to charge for what data speed, which is the basis of the billing system. The financial staff are going to ensure the invoices are issued to customers and that we collect the payments and notify the billing database that the payment has been paid. And there are various methods of receiving payments, some electronic, others other types of payments like payment by check. To the left, just below the subscriber, we have access to the customer relationship management portal. So the subscriber can log into his or her account, check information about payments, get past invoices, and also open a help desk ticket. And so we have the support staff who communicate with the help desk in order to help the customer. And the support staff will also take phone calls. Up at the top, we have the network monitoring and alerting, which also communicates to an API interface to the broadband network gateway. That's logging the network status information. And if some part of the network fails, we issue a work order to the field service technician. So a pretty straightforward system. It gets complicated when we have a triple play where we're actually billing for 3 different services. The subscriber may choose only one of the services, not the others. And this shows the software functionality that the management system might have for the sales staff, support staff, the manager, the network staff, and the billing staff. And we have demonstration networks if you want to see more of that. These types of regional systems can be integrated with a telco billing system because the cloud management for the broadband network gateway also has an API which can be used with an existing billing system. And so the existing billing system can communicate with the cloud and manage smaller regional networks. So it becomes very easy for an existing telco to expand his footprint throughout the country. Finally, the summaries, the challenges and benefits for the ISP. Well, installing fiber requires a lot of additional skills like cable splicing. And the biggest challenge that ISPs face right now is getting access to skilled people. There's a huge shortage of skilled people who have the skills to install the fiber networks, for example, cable splicing, that type of thing. It's a skill which requires training. And a lot of the fiber companies have training programs in order to get people up to speed so they're able to roll out the networks. The fiber to the home is a big investment for the ISP, and amortization of that investment takes a much longer period than for a wireless network, for example. However, the ISPs have the help that I mentioned from the government, so they have access to funds in order to build out the networks. The management of a fiber network is identical to any other type of network, any ISP or WISP network. And there are many benefits to providing this service. For example, customer satisfaction is going to be much higher than with other types of services because the speed is much faster, the reliability is much better, and that translates to customer loyalty. So we have high customer loyalty, what the telco companies call churn, which is the turnover of customers is low. And the advantage for the ISP is that the faster speed permits the offering of additional services. So we can offer these triple play services, or we can offer even additional services. And it's very easy to market fiber to existing customers of DSL or cable or even wireless, and we can encourage them to move to the new fiber systems. Finally, Flytec carries all these components that you need to build out a fiber network: the OLT, the splitters, the ONT, the BNG. They also have a lot of the other components that you need for the infrastructure to build out the networks. And so you can contact your representative in Flytec in order to find out availability and pricing of these components. Okay, so let me go back here. The last page has contact information. If you want to get in touch with me, you can do it through Flytec.